All right, so let's go through a Van der Graaf problem. So let's say we had a Van der Graaf generator, and the person touches the Van der Graaf generator for 100 seconds. Obviously, that charge is going to start to build up and up and up. The hair might start to stand up like this. The current running through the Van der Graaf generator is 0.5 amps. Now, what current is measuring, it's measuring how many coulombs of charge are flowing per second. So 0.5 amps means that there's 0.5 coulombs for every second. So that means it's going to be 50 coulombs total. Not realistic, but we're going to go with it. The surface area of the Van der Graaf in person is 2 square meters. The person gets shocked when they are standing away from something and it's 10 centimeters away from them. Let's say I was right here, the little arrow here, zap, they're going to get shocked. And the voltage on the Van der Graaf is 120 volts. So here's some questions we can ask. What's the total charge on the Van der Graaf? What's the capacitance on the Van der Graaf? What's electrical force and electrical energy on the Van der Graaf at 10 centimeters away? Well, here's how you can do that. Current is equal to charge over time. If you remember in the problem, it says 0.5 amps. That is the amount of charge and the amount of time. Sorry, this is the current, sorry. And the amount of time is 100 seconds. So the charge would just be time times current. It would be 0.5 times 100, which would be 50 coulombs. Not realistic, but we're going to go with that. Capacitance is 2 equations for capacitance. One is charge over voltage, and the other one is this constant, 8.85 times 10 minus 12 times the surface area, which we do know, which is 2, and then divided by the distance, which was 10 centimeters or 0.1. Electrical energy is equal to voltage times charge. It's also equal to K times Q divided by R. Well, this is probably a quicker way to calculate it. And electrical force is equal to K times Q over R squared. What we could do to simplify this is we can just call this Q squared, because we can assume that each of the charges is the same. Hopefully that gives you some hints on the actual problem in the problem set. It's not exactly the same, but I think people are confused about knowing how to calculate the charge and then going through like the different equations. So hopefully that helps.